everyone. This is Nagalakshmi Devi, Assistant Professor, Department of Freshman Engineering, IARE, Hyderabad, Telangana. Now today topic is discrete random variable problems. Now the first problem is, from a lot of 10 items containing 3 defectives, a sample of 4 items is drawn in random. Let the random variable x denote the number of defective items in the sample. Find the probability distribution of x when the sample is drawn without replacement. Also find the mean and variance. What is mean by with replacement, without replacement means if the given any ball or something, anyone, we are replaced again in that container, that is with replacement. Without replacement means we are not again substituting that in that container. That is called without replacement. If you are choosing any one container, in the total container, it is 10 items are there. Total how many items are there? 10. In 10 items, 3 are defective. 3 items are defective. A sample of randomly we are collecting in 4 items. Randomly we are collecting 4 items. Total 10 items. 3 items, 3 are defective and 4 items are drawn at randomly. Let the random variable x denote the number of defective items in a sample. That means P is, we are considering defective items. Compulsory here we are finding either P is success and Q is failure. In that procedure, in here we are considering which one is they are given, that is P. In defective items are P. Find the probability distribution of x when the sample is drawn without replacement. Here we are just compulsory, the needed is without replacement. And finally, we are calculating the mean and variance only. Finally, we are calculating mean and variance. Okay. Now the solution. Total how many items are there? Total 10 items are there. In 10 items, 3 are defective. 3 items are defective. In 10, 3 are defective means how many good items are there? Total 7 items are good items. In randomly, we are selecting the sample items are 4. This is the total given data. In this data, the defective items means here 3. Here we are calculating x values is 0, 1, 2, 3. Why we are considering like this means we are calculating in 0 onwards. Okay, in sample space S equal to 0, 1, 2, 3, 4. For example, 0. All items are good. There is no defective items. That is the 0 meaning. 1 means 1 is defective and remaining all are good items. Like that. Okay, 0 means all are good items. Here there is no defective items. 1 means 1 defective item and remaining all are good items. Similarly, second one is 2 are defective items, remaining all are good items. 3 means 3 are defective items, remaining one is good items. This is the condition. Here defective items we are choosing. 0 means all are good items, 0 defective items. Next, in first one, x equal to 0. That means first we are choosing 0. That is all are good items, no defective items, no defective items. That means here how many are there? Total n equal to 10. N equal to 10 and x equal to 4. Here in first numerator part, number of observations by total number of observations. Total number of observations is NCX, that equal to NCX, that equal to 10C4. That is okay. In numerator part, how many defective items? Overall items are 10. In that, there is no defective items. That is, remaining good items are 7. Total good items are 7C4 by 10C4. Now 7C4 is nothing but 7 factorial. 10C4 is 6. 1 by 6 is the 0 defective items. Okay. 0 defective items are all are good items are no defective items. Anyone it is 1 by 6. The probability lies between 0 and 1. Then this is correct. And the next one is x equal to 1. Only 1 is defective. Only 1 item is defective. Remaining 3 items are good. 1 is defective. Out of how many defects are there? Previous one. How many defects are there? 3 are defectives. In 3 defectives, how many you are choosing? 1 is defective. Okay. How many good items are there? 7 good items. How many good items are there here? It is 3. Out of 7, 3 are good items we are choosing. Out of 3, we are choosing 1 is defective item. By total number of observations, 10C4. Then 3C1 into 7C3 by 10C4, that is total is 1 by 2. That the probability lies between 0 and 1. It is correct. And next one, similarly, here P of x equal to 2. P of x equal to 2. That means 2 are defective items and 2 are good items. We are choosing 2 defective items and 2 good items. That means here 3C out of 3. Defective items are 3. Defective items are 3. Good items are 7. Good items are 7. Defective 3, out of 3, we are selecting in 2. In good items are 7, we are selecting in 2. 3C2 into 7C2 by total observations, total effective items. 10C4. Then that the calculation part is 3 by 7, 3 by 10. That is also 0.33 something. Then this is also 0 and 1 in between value. Next. P of x equal to 3. Total defective items are 3 and good items only 1. Why we are choosing like this means the randomly we are choosing 4 items only. Randomly we are choosing 4 items. Here they are given it is. Randomly they are given 4 items. We are selecting randomly 4. That means here 3 plus 1 it is 4. Here 2 plus 1, 2 plus 2, 4. 1 plus 3, 4. All are good items. It is 4. Okay. Here 3 means 3 out of 3 defective items. Here 7 good items. Out of we are selecting 1. 7C1. That's why here we are choosing like this. 3C3 into 7C1 by total observations 10C4. The calculation part is 1 by 30. This is also in between of 0 and 1. Now, this is the given data. We are also calculating the mean and variance. Here, this is without replacement. Maybe with replacement is another method. That is another procedure. Here, without replacement. Now, we are using the probability distribution table 0, 1, 2, 3. That is the probability distribution values. Now, the first 0 has we get 1 by 6, 1 has we get 1 by 2, and 2 has we get 3 by 10, and 3 we get 1 by 30. Like that, we are using the table is 1 by 6, 1 by 2, 3 by 10, and 1 by 30. This is the probability distribution table. This is the completely probability distribution table. What about the next method? Next one, we are calculating simply mean and variance. What is the mean formula? Summation of xi into pi. Here xi means the I equal to 0 to 3. That means xi, x1, x0. We are considering x0 onwards. This is x0, x1, x2, x3, and this is p0, p1, p2, and finally it is p3. Total, how many are there? 4. Now, 4 random variables, that's why you get 4 only. Okay, p0 into x0 into p0 plus, x1 into p1 plus, x2 into p2 plus, x3 into p3. Now, what is x0 into p0? x0 into p0, 0 into 1 by 6, that is 0. Plus 1 into 1 by 2, that is 1 by 2. Plus 2 into 3 by 10, that is 6 by 10. Plus 3 into 1 by 30, that is 3 by 10. The total is 6 by 5. That is the mean. Next one is variance. Variance is summation. What is the variance formula? Summation variance of v of x equal to e of x square minus e of x whole square. In simply we are writing it as x square into pi minus mu square. The summation I equal to 0 to 3. Now the 0 means here 0 is the first value. 1, 2, 3. The random variables are 4. Here we are calculating like this. That is x square means x0 square p0 plus. Next, starts with x0 onwards. Next, x1 square p1 plus, x2 square p2 plus, x3 square p3. That is the first part completed. Minus mu. Mu already calculated here. That the mean mu equal to 6 by 5. That is 6 by 5 whole square. That's all. x0 is 0. x0 into p1, p0. Now calculating. That means 0. First term is already 0. 0 into something, it is 0. Next, x1 square, that is 1. 1 into p1. P1 is 1 by 2. Next, x square. X square means X value, X2 value is 2. 2 square, that is 4. 4 into 3, that is 12. Okay, 4 into 3 by 10. That means nothing but 12 by 10. And the next one is finally, this one is 3 square, that is 9. 9 into 1 by 30. Next, 36 by 25. The total calculation is, we get finally 1.16. 1.16 the final variance formula. Final variance value. Okay. Here, this is not in between 1 and 0 and 1 in between. Mean and variance are different. The probability is always lies between 0 and 1, but the mean and variance is different. That is not in fixed with 0, not in fixed value. Okay, here only fixed with the probability value is 0 and 1, not remaining all. Mean and variance is different. Okay, 6 by 5, the mean value, and variance is 1.16. That's all. This is the mean, and how to calculate the mean and variance means like this. In the given data based, we are calculating mean and variance. Next one. A player tosses 3 fair coins. Here, we are choosing 3 coins. A player tosses 3 fair coins. He wins 500 if 3 heads appear. If 3 coins are head, he wins 500 rupees. If 3 heads appears, okay, 300 rupees if 2 heads appear. 2 are heads appear, and remaining, what about remaining? Remaining, that is nothing but tail. That he wins only 300 rupees. And 100 rupees win if 1 head is occur. 1 head is occur, remaining 2 are tails, he wins only 100 rupees. Only 100 rupees. Next, final one. He loses 1500 rupees if 3 tails occurs. If all are tails not appeared in head, then he lost 1500 rupees. That is minus. These are, we are getting profit. Here minus 1500 means it is loss. He lost 1500 rupees. Finally they are asking, find the expected value. Find the expected value of the players. What is the expected value means? Here expected value is nothing but a mean, mu. Okay. Now the given data based, we are calculating like this. Let X denote the gain. Here just they are given X is gain. In earlier problem, X given defective. In this problem, we are calculating the gain. Then the range of X is, first one is 15 minus 1500 rupees. Next 100, 300, 500. The total data. First, how many are there? Total it is 4. Next, the sample space S equal to N of S. It is 2 cube. That is nothing but 8. That equal to how many tails are there? In one time, randomly we are using the 3 coins at a time. We get 3 R heads. Next, 2 head and 1 tail. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. And finally, all are tails. In this chosen, then already all are heads means we get here it is 500 rupees. 500 rupees. One chance is occurred. Next chance is 300 rupees means 2 heads. 2 heads, any chances, in any placement. 1, 2 and 3. It is 300 rupees. 300 and 300. That means only 1 300 only. That is one chance. 1, 2, 3, 3 chances are there. 500 we get 1 chance. 300 we get 3 chances is there. And next chance. Next, all are tail. That means this one. All are tail. Only 100 rupees. Only 1 chance. Only 1 chance is there. Here only 1 chance is there. All are tails. Okay. Sorry. All are tails means 1500 loss. Okay. 1500 loss. All are tails means 1500 loss. 1500 loss is one chance. It is loss. It is loss. It is loss. Already 100 means 1 head, 2 tails. 1 head, 1 place. 1 head, 2 place. 1 head, 2 tails. This is also 3 places. 3 places. Total 1 plus 3, 4, 4 plus 3, 7, 7 plus 1. Total 8. 8 occurrences completed. This is the total data we are selecting completely we are arranging completely. Now the problem is first one. 500. P of x equal to 500. Then P of x equal to 3. 3 are heads. Then the probability all are heads. That is 1 by 8. The total outcomes are total n equal to n of s equal to 8. N of a by n of s. N of s equal to 8 already. N of a equal to only one chance is there. That is 1. And the probability P of a equal to n of a by n of s. P of a equal to n of a by n of s. Then n of a is only one chance. And n of s equal to already we know that is 8. Then we are calculating. Next, x equal to 300. That means 2 heads and one remaining one is tail. Total chances are how many are there? Total 3. Then that is 3 by 8. 3 by 8. Next, only one head, 100 rupees. He gained profit is 100 rupees only. That means one head remaining 2 are tails. One head remaining 2 are tails. That is also 3. Earlier it is 3. That is 3. That means 3 by 8. He lost. All 3 are tails means he lost 1500 rupees. That means minus 1500. That is only one time is occurred. That is 3 tails. It is 3 tails is there. Then that is 1 by 8. Out of 1 by 8. Out of 8, all are tails. 3 tails are occurred in only one time. That is 1 by 8. Now expectation E of x equal to, just they are calculating about the expectation only. Then the expectation formula is E of xi into pi. That equal to we are calculating the total. We get the answer is 25. Then it is 25 rupees. That is simply 25 rupees. 3 into calculation means 3 into 1 by 8, 2 into 3 by 8, 1 by 1 into 1 by 8. Like this we are calculating that one. The total amount is 25 rupees. Now the table, for example, we are considering table only 0, 0, 1, 2, 3. Okay, that is okay. First of all, we are calculating. We are using that one and also 0. Probability distribution table 0, 1, 2, 3. That 0 means here we get my 1 by 8. Now the 1 means here we get 3 by 8. Again 2 means here we get 3 by 8. Next 3 means 3 by 1 by 8. Now expectation equal to summation of E of x equal to mean mu equal to, that formula is xi into pi. Xi into pi means 0, p naught, this is x naught, x1, x2, x3. This is p naught, p1, p2, p3. That means p naught into x naught plus p1 into x1 plus p2 into x2 plus p3 into x3. That equal to 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. Total we get it is 25. Total it is 25. Okay, this is the complete solution. Next one. 2 dice are rolled at random. Find the probability distribution of the sum of the numbers on them. 2 dice rolled. 2 dice are thrown at a time. Here this is a cube of one die and another die. These 2 dice are rolled in randomly at random. Find the probability distribution of the sum of the numbers on them. We are finding this probability distribution of sum. Also find the mean and variance. Also we are finding the mean and variance of the distribution. This is the given completely. 2 dice are thrown means here 2 dice, that is total n of s equal to 36. 2 dice. Wow, how many faces are there? It is totally 6 faces are there. This is cube. Then we get only 6 faces are there. In cuboid it is 6 faces are there. 6 faces, that means 1, 2, 1, 2, 3, 4, 5, 6. All 6 faces are there. Similarly here also there. Then n of s equal to 36. Okay. When two dice are thrown, let x be the random variable representing the sum of the numbers of points on throwing two unbiased dice. Unbiased dice means it is perfectly arranged. Unbiased dice. The sample space is equal to here. We get in this area we get n of s means only 36 sample spaces are there. That 1 comma 1 1 comma 2 like that. That is arrangement like this. 1 comma 1 1 comma 2 1 comma 3 1 comma 4 1 comma 5 1 comma 6 continues this process up to 6 comma 1 6 comma 2 6 comma 3 6 comma 4 6 comma 5 and 6 comma 6 like this. The total arrangements are 36. Okay, the sum is 2. Here sum is 2 means here sum is 2. That is only we get one chance. 1 by 36, 2 by. Earlier we are discussing this one, but we are in that problem. We are not using we are not calculating mean and variance. We are calculating here it mean and variance. Okay. Now here the sum is 3. The sum is 3. How many are there? Events is 2. Here the sum is 4. The sum is 4. How many events are there? It is 3. The sum is 5. How many occurs are there? How many events occurs? Here it is 4. The sum is 6. How many occurs are there? It is 5. 1, 2, 3, 4, 5. Next, 7. 7 means 1, 2, 3, 4, 5, 6. Next, 8. 8 means how many you get? 5. 9. Next one is 9. 9 means we get 1, 2, 3, 4. 4 we get. Next 10. How many we get? The occurrences, the chances. The chances is 3 only. Next 11. The sum is 11. The chances are 2. The sum is 12. The chances are only 1. Now like this, P of x equal to 2. The chances is 1 by 36. Only one chance. P of x equal to 3. Only 2 chances are there. 2 by 36. Here same formula. N of a by n of s. P of a equal to n of a by n of s. N of a is 1 and n of s equal to 36. We know that earlier method same. The probabilities distribution is 2 to 12. Arranged like this. 2 we get the probability expectation is 1 by 36, 2 by 36, 3 by 36, 4 by 36 like this. The finally we get 1 by 36. The total arrangement we are adding in this area, in this arrangement we get the answer is 1. Then the probability is 1. It is correct. P of x equal to 1. That is the calculation. Here total we are calculating like this. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 5, 26, 26 plus 4, 30, 30 plus 3, 33, 33 plus 2, 35, 35 plus 1, 36, 36 by 6, 36, it is 1. Then your problem is correct. If it is not in 1, then any mistake is there in earlier procedure, we can cross check it again. Now they are calculating about the mean and variance. Mean. Here mean mu equal to summation of xi into pi. That means p naught. This is x naught, x1, x2, x3, x4, x5, x6, x7, x8, x9 and x10. These are the arrangement of x. Next, similarly, arrangement of probability. P naught, P1, P2, P3, P4, P5, P6, P7, P8, P9 and finally P10. Now the arrangement, that is P0 X0 plus, otherwise P1 X1 is correct, X0 P0 is correct, X0 P0 plus X1 P1 plus X2 P2 plus X2 P2 plus up to so on X10 P10. Now simplification. 2 into 1 by 36 plus 2 into 1 by 36 plus 3 into 2 by 36 plus up to so on. Like this, 12 into 1 by 36. Finally, the answer is 7. Finally, the answer is 7. And next one is variance. The mean value is 7. That means your mean mu equal to 7. Here the variance means, variance formula we know. That is e of x square minus e of x whole square. That can be written as like this. Xi square into pi minus mu whole square. Here already we know mu is nothing but 7 square. And simply here it is x1 x0 square p naught plus x1 square p1 plus x2 square p2 plus up to so on plus xn plus x10 square p10 minus mu means it is 7 square it is 49. Now the final value is the solution is 5.8. There is the final solution of the variance. Here simply they are asking like that only. Two dice are rolled at a random. Here two dice are rolled at a randomly. These two dice are thrown at randomly. Find the probability distribution of the sum of two numbers on them. Sum of two numbers. These two numbers sum is at randomly. Sum of the numbers on them. Also find the mean and variance of the distribution. Simply they are asking mean and variance only. Okay, that means mean variance we need. The final, first of all, we are calculating the probability distribution table. That is this table. How to find this table means by using this the N of S, total 36 items. By using given data, we are arranging like this. Okay. 1 chance, 2 chances, 3 chances, 4 chances, 5, 6, 7, 8, 9, 10, 11, 12, up to so on. Now, this is the final one. And the next topic is continuous random variable. Let f of x be the probability density function of a continuous random variate. Then mean equal to mu equal to e of x equal to integral minus infinity to infinity x into f of x dx. In earlier, mean mu equal to summation I equal to 1 to n, otherwise 0 to n, x into p of x. Here it is x into f of x dx. Already continuous distribution we can see. The arrangement is in terms of infinity. Integral minus infinity to infinity f of x dx equal to 1. We know in earlier. Here mean also arranging like that. Integral minus infinity to infinity x into f of x dx. That is mean. Next, otherwise expectation also same. Variance equal to v of x equal to otherwise x equal to sigma square equal to integral minus infinity to infinity x square f of x dx minus mu square. In earlier it is x square into pi minus mu square. Here it is x square into f of x dx minus mu square. Next, v of x equal to same in earlier formula. V of x equal to e of x square minus e of x whole square. That equal to sigma square equal to integral minus infinity to infinity x minus mu whole square f of x dx. We are writing like this or this. That is your choice. We are arranging this one or this one. Both are same. Just simply we are common with f of x dx only. That's all. Next one. Third one. Median is the point which divides the entire distribution into two equal parts. For example, I am choosing the integral minus infinity to infinity. Arranging in equal subparts means in between we are using in the origin 0. That means the integral minus infinity to 0 plus 0 to infinity. Okay, that is the median. Here mid value is 0. That's all. Mean deviation. Mean deviation about the mean mu is given by mean deviation about mean is given by mean deviation about mean. That is the meaning. About mean is equal to integral mean deviation about mean mu is given by integral minus infinity to infinity x minus mu f of x dx. Now, next one. Mode is the value of x for which f of x is maximum. In a mode is always the f of x is maximum. If it is either 0 to greater than value or 0 to less than value, it is maximum. Mode is nothing but derivative of f of x and it is equal to 0. It is nothing but derivative f of x dx is equal to 0. Always it is fixed. The mode the value is maximum, the x value is always maximum and the derivative is 0. The derivative part is nothing but 0. That is the mode condition. Now the continuous random variables first problem. How to find the continuous random variable problems? A continuous random variable x is defined by, here they are given in subparts, each and every one subpart. The continuous random variable always lies between minus infinity to infinity. Here they are given always, they are not given in terms of minus infinity to infinity. Sometimes they are given in subparts, minus 3 to 3. If the arrangement is like this, the continuous process, that is piecewise continuous process, that is minus 3 to minus 1 plus minus 1 to 1 plus 1 to 3. Elsewhere means remaining all are zeros. Up to these are the values. Remaining this area and this area all are zeros. That means it is plus infinity and this is minus infinity. The remaining all are zeros. For example, we are choosing 3 to 4. For example, we are choosing 3 to 4 means that the part is nothing but 0. They are given 0. If we are choosing minus 2 to minus 3, for example. Okay, that means this part is nothing but 0. Remaining all are zeros. They are telling remaining all are zeros up to ending. Okay, for example, minus 3 to minus 1, the value is this one. Minus 1 to 1, the value is this one. 1 to 3, the value, the f of x function value is this one. These three are the function values of the minus 1, minus 3 to minus 1, minus 1 to 1, 1 to 3. This is the given condition of the problem. And verify that f of x is a density function and also find the mean of the x. Here they are asking mean mu. And another one is find f of x is the density function or not. Okay. Function, density function they are asking. Now the formula. F of the density function first condition is always f of x greater than or equal to 0. Already we know the properties of the continuous random variables property. The f of x is greater than or equal to 0. Integral, the formula is like this. The property, the first property like this. F of x is greater than or equal to 0, comma, minus infinity less than, x less than infinity. In this arrangement, here we are fixed with minus 3 to 3. In this arrangement, integral minus infinity to infinity f of x dx can be written as like this. Integral minus infinity to minus 3. We are using subparts. Next, minus 3 to minus 1. Minus 1 to 1. 1 to 3. 3 to infinity. In this total arrangement, why we are fixed like this means, in earlier they are given, in our question they are given minus 3 to minus 1. Minus 1 to 1, 1 to 3. These three are fixed. The remaining all are, we get the 0 value. That's why we are arranging like that. Minus infinity to minus 3, the total, this term is 0. This total term is 0. And minus 3 to minus 1, the value of the function is 1 by 16 into 3 plus x whole square. This value is, my integral minus 1 to 1 value is 1 by 16 to x minus 2 x square. And 1 to 3, integral 1 to 3 value is 1 by 16 into 3 minus x whole square. And finally, 3 to infinity value is 0. We are simplification these three only. We are arranging these three and simplified these three. The final answer is 1. This is density function. The density function is satisfied. Okay, since f of x satisfies the requirements for a density function, therefore f of x is a density function. If it is not equal to 1, the density function is not satisfied. Next, if the first of all they are asking density function and then asking the mean also. The mean arrangement is integral minus infinity to infinity x into f of x dx. In same arrangement here also we are arranging minus 3 to minus infinity to minus 3, integral minus 1 to minus 3 to minus 1, integral minus 1 to 1, integral 1 to 3, integral 3 to infinity. These are the arrangements of integral minus infinity to infinity. If first one, this is also 0, and finally last one also 0, remaining these three are the conditions. How we are arranging like this means, if for example, I am considering integral minus infinity to infinity. The first cutting is minus 3, next minus 1, next 1, next 3. Here, this area to this area total is 0. Earlier they are given like that only. Next, this part minus 3 to minus 1. Minus 3 to minus 1 is 1 by 16 into 1 by 16 into 3 plus x whole square. And next one, one by 16 into 3 plus x whole square. Next, minus 1 to 1, that is 1 by 16 into 6 minus 2x square. Next, last arrangement is 1 to 3. 1 to 3 is 1 by 16 into 3 minus x whole square. The remaining all are zeros. That means 3 to infinity, any part is 0. That's why I am considering it is 0. Here minus 3 to minus infinity to minus 3, the total value is 0. That's why I am considering it is 0. We are calculating only in between of these three, in between of these two, the remaining three elements, that is minus 3 to minus 1, integral minus 3 to minus 1, plus integral minus 1 to 1, plus integral 1 to 3 only. The final answer, simply it is 0. Sometimes it will be comes like this, always not like this. Simply in this time we get the answer is 0. That's all. Okay, this is the mean of the given problem. Continuous and variable problem, the mean value is 0. The mean value is 0. The density value is fixed with it is 1. That's all. Now the next one. The troubleshooting capability of an IC chip in a circuit is a random variable x whose distribution function is given by. Here the given function is f of x. Now the arrangements are less than 0, all are zeros. Greater than 0 value, greater than and equal to 0 values are 1 minus 9 by x square only. If you are arranging like this, or then 0 less than elements are zeros. Remaining all are, for example, we are choosing 0 less than values, minus 0.1, minus 0.2, minus 0.3, like this up to so on, minus 1, minus 2, all are zeros. 0 and above, remaining all are up to infinity, up to minus infinity. Here it is up to infinity, all this total data is 1 minus 9 by x square. 0 and above all are 1 minus 9 by x square. Below 0 items are 0. Below 0 functions are 0. Above 0 and above functions are 1 minus 9 by x square is the data, where x denote the number of years. Here x indicated by number of years. The IC chip circuit, how many years it is fixed with, that one. We are calculating that only. Find the probability, how many years? Okay. Find the probability that the IC chip will work properly. How many years the IC chip properly working? Next, now the first condition is less than 8 years. Next, second one is beyond 8 years. Beyond means above by 8 years. And that means, that is the meaning. Next, between 5 to 7 years. In between of 5 to 7 years only. Anyway, from 2 to 5 years. If it is working, if it is perfect or not, the working condition is 2 to 5 years. That is the meaning of this one. These are the given statements or given conditions. First of all, we can check it one by one. We know f of x equal to p of x less than or equal to x. Here we are using density condition. Here we are using density condition in IC chip. For example, in ELA method, we are using density method. Why? Because the given data is f of x, capital F of x. In terms of small f of x, it is a continuous random variable. In capital F of x, it is density of the function, cumulative distribution function. Now, here f of x equal to integral 0 to x f of t dt. In between, we are using t. Now, arrangements are 0 is less than x less than 0 and greater than or equal to 0, it is 1 minus 9 by x square. Now, the first part is in between value. That's why here t is equal to, we are considering like this. First one is less than 8. That's why I am considering less than 8. Integral 0 to 8 f of t dt equal to less than 8. But it is 0 to 8 condition. In earlier it is 0 to 8 in this place. In this place. That's why we are considering 1 minus 9 by x square. Here x is 8. Here f of integral 0 to x. Here x is 8. Then 1 minus 9 by 8 square. The answer is 0.85. Next one is greater than, that is here beyond 8 years. Above 8 years, that means 8 years above. That means x greater than 8. X greater than 8 means 8 to above 8 to up to infinity terms. We are calculating, it is difficult. That's why we are ending 1 minus remaining something. That means x greater than 8 means 1 minus x less than or equal to 8 condition. We are choosing that method. 1 minus p of x less than or equal to 8 condition. 1 minus, already we are calculating p of x less than or equal to 8. That value is 0.8594. Then the value is 0.14. This is the x greater than 8. Beyond the 8 value is, beyond the 8 years value is, the probability is 0.14. Next, in between of 5 and 7. Here the probability continuous random variables properties we are using in that property, that is f of b minus f of a. F of b here it is 7 and a is 5. F of 7 minus f of 5, that is 1 minus f of 7, capital F of 7, capital F of 5. Here compulsory we are remembering that capital. That means cumulative. That means 1 minus 9 by x square. Here x equal to 7 square. Similarly here also it is 5. X value is 5. 1 minus 9 by 5 square. The total value is 0.1763. Now last one is anywhere from 2 to 5 years only. Anywhere 2 to 5 years. That means the arrangement is also same like that only. It is f of 2 x 2 less than or equal to x less than or equal to 5. F of 5 minus f of 2. 1 minus 9 by 5 square minus f of, this is also 0. The answer we get 0. Y means 1 minus 9 by 2 square. F of 2 square. That is 4. 1 minus 4. 9 by 4. Minus, okay. 9 minus 4. Okay, minus 5 by 4. Here, the p of 2 less than or equal to x less than or equal to 5 means f of 5 minus f of 2. We are arranging x equal to 5 and x equal to 2. The final is 0.64. That's all. The total, the troubleshooting capability of IC chip circuit, in a randomly we are arranging the work, how many years it will be worked. In first one less than, by using probability. By in less than 8 years, we are calculating less than 8 years. Beyond 8 years, between 5 to 7 years, anywhere from 2 to 5 years. We are calculating all are there. All are the total completion of the arrangements. And next one. The daily consumption of electric power in millions of kilowatts hours is a random variable having the probability density function. The given data, x greater than 0, the function f of x equal to 1 by 9 into x into e power minus x by 3. If x less than or equal to 0, it is 0. If it is arranging like this, 0 and remaining less than values are all are 0. Above 0, above values all are 1 by x into e power minus x by 3 by 9. Next, they are asking if the total production is 12 million kilowatts per hour, determine the probability that there is power cut or shortage on any given data. Given data based, we are using a power cut shortage as there or not. We are calculating like that. Power supply is inadequate if daily consumption exceeds 12 million kilowatts. Exceed, here it is compulsory they are given exceed 12. That's why we are considering their total production is 12. That's why it is we are considering 12 exceed. That's why remaining arrangement is 12 is exceed means x greater than 12. We are not considering 13 to minus infinity plus infinity. That's why we are considering 1 minus like that. That's why we are considering probability that the power consumed in between 0 and 12 is, for example, we are choosing like this 0 and 12 consuming. But then we get remaining 1 minus like that. That's why, for example, we need x greater than 12. Finally, we are not collecting easily x greater than 12. That's why I am choosing 1 minus p of x less than or equal to 12. First of all, we are calculating p of x less than or equal to 12. Then after, we are writing as 1 minus p of x less than or equal to 12. What about p of x less than or equal to 12 means? Here we are arranging like this. P of 0 less than or equal to x less than or equal to 12. That is integral 0 to 12 f of x dx equal to 1 by 9. Here integral 0 above all values are x into e power minus x by 3 by 9. Above, here also it is 0 to above. Then applying that formula x into e power minus x by 3 dx. Here 1 by 9 is a constant. We are eliminating the integral outside. Then this is the arrangement of the integral formula. Applying the uv. How we get means derivative of integral of uv means derivative of uv equal to u into derivative of v plus v into derivative of u. In like, next integral of uv means u into integral of v minus u derivative of u into integral of v plus alternatively we are arranging the plus minus. Here first one is plus and next one is minus, next one is plus like this. U double dash triple integral of v minus u triple dash fourth integral of v plus continuing this process. By using eyelet, we get x is the first one, u, and e is the v. That means x into u is same, x into derivative of u into integral of e power minus x by 3. That is e power minus x by 3. Integral of e power minus x by 3 means e power minus x by 3 by minus 1 by 3 minus x derivative. Here u is completed, integral of v is completed. Next minus u dash. U dash means x derivative. The x derivative is 1. Next again the integral of this part, this one only, that is e power minus x by 3 by already 1 by 3 is there. Again this term of the 1 by 3. This term of the integral is again minus 1 by 3. That is total 1 by 9. Completed 1 by 9. Next step plus 1 derivative. That means u double dash. 1 derivative is 0. The total term is 0. And remaining terms also zeros. That's why we have stop here only. That is the integral of x into e power minus x by 3 dx. Now substituting the limits, integral 0 to 12, upper limit is 12 and lower limit is 0. We get the answer is minus 1 minus 5 into e power minus 4. And simply I am telling already we know 1 minus p of we know we want p of x greater than 12 means we are using 1 minus p of x 0 less than or equal to x less than or equal to 12. Already here we are calculating p of 0 less than or equal to x less than or equal to 12. Substituting that 1 minus p of 0 less than or equal to x less than or equal to 12. We get 1 minus this equation value. We get the 0.09 is the power supply in greater than 12 kilowatts, million kilowatts probability. This is the problem conclusion. Next one. Find the constant k such that f of x equal to, here 0 and 3 in between value is k into x square. The remaining all are zeros. That means we are choosing 0 to 3. The value is k into x square. The remaining all are zeros. Is probability function. This is the given, we are finding the constant k, that means this constant k, and find the cumulative probability distribution function. Already in earlier session we are seeing the cumulative probability distribution formula. In that formula we are substituting here, we get the cumulative probability distribution function. And the second one, they are asking 1 less than x less than or equal to 2. 1 less than x less than or equal to 2 also. This is in between of 0 and 3. We get the k into x square. Okay. Next one. The given function f of x solution. The given function f of x equal to k into x square if 0 less than x less than 3. 0 otherwise. The given data. What is the cumulative probability distribution? That is integral minus infinity to infinity f of x dx equal to 1. Here f of x is nothing but k into x square. How we get k into x square? The remaining are integral minus infinity to infinity f of x dx equal to 1. This can be split into subparts. Integral minus infinity to 0 f of x dx plus 0 to 3 f of x dx plus integral 3 to infinity f of x dx is equal to 1. This part is 0, we know. This part is also 0. The remaining is integral 0 to 3 f of x dx is equal to 1. That is this one. Now the f of x value 0 to 3 f of x value is k into x square dx equal to 1. In simplification, k is a constant. X square integral value is x cubed by 3. Substituting of 0 and 3, we get the here k equal to 1. K into 3 cube, 27 by 3, that is 9. 9 equal to 1. K equal to 1 by 9. We get the k value is 1 by 9. Here x cube by 3 means 27 by 3, that is 9. K into 9 equal to 1, then k equal to 1 by 9. We get the k value. First of all, they are asking k value. Find the constant k value. Next, that is the probability of continuous random variable integral minus infinity to infinity f of x dx equal to 1. We know that is the discrete random variable function is summation of p of x dx, summation of p of x equal to 1. In that discrete random variable. In continuous random variable, it is integral minus infinity to infinity f of x dx equal to 1. We are choosing in sub equal parts. We get remaining 2 are zeros. We get only integral 0 to 3 f of x dx equal to 1. That k value equal to 1 by 9. Next step is cumulative. Cumulative frequency, already we know earlier property, that is integral minus infinity to x. We are substituting some in between sub equal parts of the x. We are choosing that is x. Integral minus infinity to x f of x dx. F of x equal to integral 0 to x 1 by 9. Here the function is, what is the function? X square by 9 dx. The function is k by x, k into x square. K value already we know. We get earlier only. That is 1 by 9. That's why we are substituting 1 by 9 here only. Earlier it is k into x square. The k value is 1 by 9. Okay. Now substituting that value, we get the 1 by 27 into x cube. Now the function is simply we are writing as cumulative distribution function. This is cumulative distribution function is if f of x greater than 0, in earlier it is k into x square. Now this is 1 by 27 into x cube. 0 remaining others. That is the cumulative distribution function. They are asking cumulative distribution value, not in value. They are asking find the cumulative distribution function f of x. That's why we are simply writing function also. If they are asking only value, we are stopping here only. Compulsory, we are checking that also. Okay, here they are asking cumulative distribution function f of x. That's why function also we are substituting. And finally, they are asking P of 1 less than x less than or equal to 2. That is in between of 0 and 3, in between the value of 1 and 2. Then we are arranging this one 1 to 2, integral 1 to 2 into k into x square dx. The k value is 1 by 9, that equal to 7 by 27. That's all. Don't take the 1 by 27 into x cube. That is cumulative distribution function. Here they are asking probability distribution function, continuous probability distribution function. That's why here we are taking k into x square dx only. The final answer is 7 by 27. It is lies between 0 and 1. Then your problem is correct. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.